गया। गुड इवनिंग ऑल। ओके, शुभ संध्या। ओके वरुण, तो वरुण, यश, वसंत, प्रहर्ष, चैत्र, हर्ष, आशीष, ऋषि, हर्षिल, साहिल, इतने लोगों के नाम हैं और सामने तो 5 ही दिख रहे हैं। 1 2 3 4 5 6 7 8 9 10 11 है तो 7 ही। ये क्या गुड इवनिंग करके गायब हो गए? ओके, आशीष प्रेजेंट। और बाकी कौन कौन अभी प्रेजेंट है? ओके, आशीष, यश, वसंत, हर्ष, सुभाश्री। हाँ, गुड इवनिंग। तो जो लास्ट टॉपिक हमने किया था उसके बाद we have completed preparation of aldehydes and ketones, right? Now today we will start physical properties of aldehydes and ketones. Physical properties of Thank you, Subhashri. Okay, तो physical properties of aldehydes and ketones. So first हम लेते हैं physical state. So tell me, जो lowest member है means first member of aldehyde and ketone, that is formaldehyde H, C double bond O H. So formaldehyde is gas. Formaldehyde is gas, but rest of the members are either colorless liquid or solid, depending upon the size of alkyl groups or depending upon the number of carbon atoms, we can say, because as number increases, van der Waals attraction is proportional to, tell me, van der Waals attraction किसके किसके proportional है? बोलो. Yes, van der Waals attractions are proportional to proportional to molar mass. And what about others? And anything else? Molar mass, it is also proportional to, yes, size, proportional to number of electrons, yes, surface area. Okay, Kashmira, good, welcome. Inverse the 7th power of the intermolecular distance is very good, great. So van der Waals attractions are proportional to, means we are not going in detail Kashmira, हम क्या करते हैं, सिंपल ये फंडा रखते हैं. तो क्या है, इट इज प्रोपोर्शनल टू नंबर ऑफ कार्बन एटम्स, राइट. So as number of carbon atoms increases, obviously molecular mass increases, so size increases, number of electrons increases, and so is the van der Waals attraction. That's why lower member is gas and higher members are, heavier members are liquids and solids. Okay, good beta. So now this is the first point. It means they are colorless, liquid or solid depending upon the number of alkyl groups, size, as well as number of electrons, number of carbon atoms. And as number of carbon atoms increases, obviously second point is boiling point. So boiling point, you know, if we compare aldehyde or ketone with alkanes and ethers, obviously this part means CO group is polar, alkanes are non-polar, ethers are very slightly polar. That's why boiling point of carbonyl compounds, aldehyde and ketones combinedly known as carbonyl compounds. So if we compare boiling point of carbonyl compounds is greater than ethers, alkanes, okay, or they are sometimes they are inverse of each other, means ether is on this side. Okay, but if we compare it with alcohols of comparable molecular masses, so tell me, out of carbonyl compound and alcohol, which one has higher boiling point? See, in carbonyl compounds there is dipole-dipole attraction, right? Because it is like this, okay, dipole-dipole attraction, okay. So out of carbonyl compounds and alcohols, which one has higher boiling point? Very good. Obviously alcohols, because alcohols are associated through hydrogen bonding. There is H bonding. Here there is dipole-dipole attraction, right? So this is the order. Is it okay? Yes. Yes. Because hydrogen bonding is absent in carbonyl compounds, there is simple dipole-dipole attraction, and hydrogen bonding is stronger than dipole-dipole attraction. Okay, so this is about boiling point, and as carbon atoms increases, boiling point increases. Okay. That means if we have CH3, CH2, CH2OH, or simply CH2OH, it is more than CH3, CHO, which is more than CH3O, CH3, and it is greater than CH3, CH2, CH3. So this is the order of boiling point. Alcohol highest, then aldehyde, then ether, and last one is alkane. Okay? Right? Now come to solubility. So tell me, are they soluble in water or insoluble? Yes. Solubility. Okay. See, actually there is no hydrogen bonding involved, but they can form hydrogen bonding with water like this. Okay. Right? So in this way, this is the case of hydrogen bonding with water. Now, as number of carbon atoms increases, as number of carbon atoms increases, obviously solubility in water decreases because of the increase in non-polar part. So up to 4 carbon atoms they are soluble. Okay, but then for next members, solubility goes on decreasing. As carbon atoms increases. You know that because non-polar part increases, so hydrogen bonding becomes weak. Hydrogen bonding becomes weak, right? Yes, because of chain. Okay. And because of that hydrocarbon part, they are soluble in organic solvents. Okay. Okay. So now let us talk about smell. Yes. What about smell? So lower members of aldehyde and ketones have unpleasant smell. And benzaldehyde what is the smell of benzaldehyde? Benzaldehyde has bitter almond smell. But as number of carbon atoms increases, the smell becomes less pungent and more fragrant. That's why it can higher members of aldehyde and ketones can be used in perfume industry. Means as number of carbon atoms increases, smell becomes less pungent and more fragrant. That's why it can be used in perfume industry as a perfuming agent, as a flavoring agent. Okay, it can be used, higher members of aldehyde and ketones can be used in perfume industry as a flavoring agents. That's all about physical properties of aldehydes and ketones. I think you don't have any doubt up to this. Any doubt? Yes, anyone? Any doubt up to this? Okay. Structure of carbonyl group. Structure of carbonyl group. So in carbon and oxygen, carbon form 3 sigma bonds and there is one pi bond. Between carbon and oxygen. But when this bond is formed, pi electron cloud is more towards oxygen. It is more towards oxygen. Electron density is more towards oxygen. It is not symmetrical electron cloud. It has unsymmetrical pi electron cloud. This is the pi bond formed. If they compare it with alkene, in alkene, same type of bonding is there, but pi electron cloud is symmetrical. Okay. Pi electron cloud is symmetrical. That is above the plane and below the plane. It is symmetrically arranged. But in carbonyl compound, pi electron cloud is more towards oxygen because oxygen is more electronegative than carbon. That you know all. Right? And this angle is almost, obviously this angle is slightly smaller than these two. Okay, it means if it is 121, it is 119. Otherwise bond angle should be 120 almost, right? Very good question. Actually, if we compare hydrogens are smaller in size, so obviously they will repel them more. So say if it is theta 1 and it is theta 2, okay, they are also there, but because of larger size of alkyl groups, exact bond angle there is no need to remember, but if we compare, obviously theta 1 is less than theta 2, right? Because of these bulky groups, they cannot come closer due to steric hindrance. That's why, and because of their small size, they can come closer. So theta 1 is always less than theta 2. Okay, Abhishek Kumar, got it? Exact angle I don't know. Okay, but it is sure that angle between CH groups, CH bonds, it is less in formaldehyde than in acetone. Okay, right? Because if you go towards that, what is the exact bond angle, then you should go through literature. But question is like comparative study. We can compare only. Okay. Because exact bond angle, that is experimental, so that we should remember. Like we know for water, ammonia, okay, common, right? Right. Now chemical properties of carbonyl compounds. Okay, before going through chemical properties, just tell me the difference between these pi bonds in carbonyl and alkene. What is the difference? Write the difference. Right, similarities and differences. Right. First, write the similarity between C double bond O and C double bond C, and then differences. Yes. Write the. Okay. First, write the similarities. Similarities. So similarity, first similarity is both the bonds have one sigma and one pi bond. Second, both will use, या both क्या लिखोगे, will तो नहीं आएगा, both use sp2 hybridized carbon, both have sp2 hybridized carbon, and third, both have planar structure. These are the three similarities between C double bond O and C double bond C. Now let us talk about differences. Both double bonds have one sigma bond and one pi bond. both use sp2 hybridized carbon. See, both have 3 sigma bonds, right? And both have planar structure. Now, differences. Yes, right, differences. Very good. Has dipole because carbon oxygen double bond is polar and carbon double bond is non-polar. Okay. Yes. Second, बोलो जल्दी. Any other difference? Carbon oxygen double bond length is smaller than that of carbon double bond length. Right? Now, yes. Any other difference? Because oxygen is smaller in size, oxygen is smaller than carbon. Bond length हो गई. And any other thing? Yes. Sahil, very good. Carbonyl group. Yeah, carbonyl compounds undergo nucleophilic addition reaction because here carbon gets positive charge and alkenes undergo electrophilic addition reaction. So these are the similarities. Very good. So what are the similarities and differences between C double bond O and C double bond C that we have done? Okay, good. Now, chemical properties of aldehydes and ketones. Chemical properties of, is it visible? Yes. Chemical properties of aldehydes and ketones. So aldehyde and ketone means there is a C double bond O where carbon has partial positive and oxygen has partial negative. So when they have positive and negative charges, pi bond shift towards oxygen, right? So when pi bond between carbon and oxygen shift towards oxygen, why is it so? Why it shift towards oxygen? Because oxygen is more electronegative. That's why obviously pi electron will go towards oxygen. So when pi bond goes towards oxygen, carbon gets complete positive charge and oxygen gets complete negative charge. So nucleophile will attack on carbon. So nucleophile will attack on carbon. So when nucleophile attack on carbon, we get this product, and obviously this carbon is sp2 hybridized. And what is the hybridization of this carbon? Yes, tell me, what is the hybridization of this carbon? First, what is the hybridization of this carbon? Beta, it is sp3 hybridized. It is like nucleophile O negative. It is like this. It is tetrahedral. This is planar. And it becomes sp3, right? So, and this is slow step, attack of nucleophile, and before going to this stage, there is a transition state where nucleophile starts attaching to the carbon, and there is a breaking of bond. It is partially negative. This is also partial negative. So when this bond is formed completely, it becomes neutral. Means bond is formed completely and this pi bond breaks. So O gets complete negative charge. So this is the transition state. And we get this product, and then H plus ion. This is fast because there is an ionic reaction now, and we get the desired product. So this is the product formed. Means in this reaction there is a why it is called nucleophilic addition reaction? Tell me. This is nucleophile obviously. But nucleophile is added here, and H plus is, what is H plus? Tell me, electrophile or nucleophile? H plus is electrophile or nucleophile? H plus ion is it electrophile or nucleophile? Obviously it is electrophile, right? So when final product is formed, compare these two. At carbon, nucleophile attached. At oxygen, electrophile attached. Means there is addition of electrophile as well as nucleophile. So why we call this reaction as nucleophilic addition reaction? Yes, tell me. Why this reaction we call it as nucleophilic addition? Why not nucleophilic electrophilic addition? Or simply electrophilic addition? Tell me, fast. Why this reaction is called nucleophilic addition reaction? We can write as R1, R2. R1, R2 may be hydrogen or an alkyl group or aryl group. Beta, what I said, nucleophile is added, electrophile is also added, both are added. Anyone who can answer? Both are in equilibrium. Because of alkox tetrahydral lactoxide intermediate is formed. It is not the case. Keep in mind, fit in your mind that the one which is added in slow step decides the rate of the reaction as well as decide the type of the reaction. If nucleophile is added in slow step, it is called nucleophilic addition reaction. If electrophile is added in slow step, that is called electrophilic addition reaction. Keep this thing in mind. In this particular reaction as well as with alkene, both are added, electrophile as well as nucleophile. But in alkene, electrophile is added in slow step. That is called electrophilic addition reaction. But here, nucleophile is added in slow step. That's why it is called nucleophilic addition reaction. Yes. Got this point? And keep in mind this thing, that the one which is added in slow step decides the type of the reaction. Okay? Now, a role of acid catalyst in nucleophilic addition reaction of carbonyl compounds. See, if we have nucleophile, we have H plus ion, then first of all, H plus ion will attack and there is clear cut positive charge on carbon before the attack of nucleophile. H plus ion is added, so this carbon gets complete positive charge. Now attack of nucleophile is easier than before. Attack of nucleophile is easier than before. That means a rate of reaction increases. That's why this is acting as a catalyst. H plus ion, if the reaction takes place in acidic medium, reaction is faster than in the absence of H plus ions. Because and H plus ions are added, then carbon gets complete positive charge before the attack of nucleophile. So reaction becomes fast. The nucleophilic attack becomes easier. So this reaction is actually pH controlled reaction. This is pH controlled reaction. That means if medium is acidic, reaction is fast. Reaction is fast. Okay? But strongly acidic medium is not recommended. Strongly acidic medium is not recommended. Like, you know that if acid is present, rate of reaction is fast. So we go on adding acid more and more. Stronger acid is added. pH we will decrease more. Then what would happen if medium is strongly acidic? Then even nucleophile will get protonated. So it loses its nucleophilic ability. Like if medium is strongly acidic, then even nucleophile will get attached to H plus, and therefore it is no more nucleophilic. Means it loses its ability to act as a nucleophile. That means pH should be low but not very low. So pH between 3 to 4 is recommended. Strongly acidic medium is not favorable. Weakly acidic medium is required. Okay? So nucleophilic addition reaction is a pH controlled reaction. First, acidic medium is favorable because it protonates the carbonyl group, oxygen of the carbonyl group, and carbon gets complete positive charge. So attack of nucleophile is easier. But if medium is strongly acidic, then H plus ion will also attack on nucleophile and loses its ability to act as a nucleophile. Rather than attacking on the carbon, it will attach to H plus because they are more in abundance is present. Right? Okay. Now that's it. Okay, so we will keep up to this today. Okay, today I was late. So anyhow, complete this one. Right? Chalo. Good night. Bye bye. Okay, bye beta.